All right, thanks for joining us. Appreciate everyone being here today. My name is Matt, and I'm with my colleague Luis here. We're from the Global Incident Response team at Sygnia. For those unfamiliar with Sygnia, we are a cybersecurity firm spread throughout the world with offices in New York, Tel Aviv, and Singapore, and we have experts in incident response, adversarial tactics, and enterprise security. The case we're going to talk about today was one of the more intriguing and interesting cases that we've had recently. It started with the FBI seizing a laptop farm and then us doing an investigation on one of those laptops and finding a treasure trove of pretty cool and interesting scripts and tools that the adversaries are used. So like I said, my name is Matt Mosley. I'm an incident response manager at Sygnia. I've been in cybersecurity for about 18 years, started off in offensive security, based out of Portland, Oregon. And then I spent the last decade in incident response and digital forensics. Luis?
Hi, again, my name is Luis Garcia. I'm a senior incident response expert at Sygnia. I've been in the DFIR space for about 3 to 4 years now. Originally starting at Strasbourg, then over to Sygnia, just same work, just on a global scale.
So today's agenda, we're going to do a little bit of background on how this case dropped into, fell on our desk, as well as a little bit of background on North Korean cyber operations over the last few years. Second, we're going to go through the tools, the modules. Luis is going to dive deep into those. And then the cool part, going to do a live demonstration. And then wrap up with how you as defenders can fight back against this. And then some key takeaways for organizations as a whole. Because this is going to be a collaborative effort here for organizations moving forward. So a little bit background on North Korea. As many of you know, and from the headlines, right? They've been pretty active, probably one of the more prominent creative threat actors on the planet, from noisy campaigns such as like the Sony Pictures hack, moving into bank heists and cryptocurrency thefts. But this one's a little bit more concerning just because this one came in as legitimate IT work, starting out posing as different employees and gaining access through nefarious ways. So some key milestones over the last 3 years. In May of 2022, the FBI, US Department of Treasury, and the US Department of State issued a warning, letting organizations know that this campaign was starting, that they were posing as legitimate employees, gaining access as legitimate workers, getting devices issued to them, and then infiltrating companies. In August of 2024 through February of 2025, 21 C2 servers were identified as being part of this operation. In September of 2024 through February of 2025, 7 organizations globally have come out and acknowledged that they were victims of this campaign. And then in January 2025, the FBI updated their notification and into a change of tactics that the North Koreans were now doing, which was an extortion attempt. Basically, they would gain access to these companies, and then they would extort the companies, threatening to release not only information that they had potentially data exfiltrated, but also access to the company itself. And so that was a significant uptick in their previous tactics. And then lastly, Sygnia saw the impacts of their financial campaigns firsthand when we investigated one of the largest cryptocurrency hacks in recent history, resulting in an estimated of $1.5 billion stolen. So timeline of events related to this case, in December of 2024, the FBI raided a laptop farm here in the United States. In that laptop farm was one of our client's devices. This device was issued to a legitimate IT worker working in DevOps. This person checked all the boxes, went through the hiring process, went through the background check, and then was hired on legitimately through this company. When the raid happened, we were notified by our client that their device was in this laptop farm, and it was handed over to us for analysis, as well as we went through and did a full threat hunt throughout the environment just to see if the incident had any more depth to it. Was there any kind of persistence, data exfiltration? How far did this really go? During that analysis, we did the host forensics. And that's where we discovered the scripts and the methods that they were using to manipulate the laptop while having remote access and maintaining that facade that they were a legitimate IT worker. We returned the laptop and closed up the case. And today we're going to go dive deeper into that tool set. But the most important thing to take away really is that this infiltration and this attack involved no malware whatsoever, right? These were just Python scripts that were running locally on the host. They didn't trigger off any normal alerts on any of our known security platforms. They used WebSockets, which is not something that's uncommon, but it's less common than what we see in normal incident response. But this WebSocket connections would allow them to communicate both ways, right, to the C2 servers. They used ARP packets, which was something that we haven't seen before, where they would inject their payloads into the ARP packets, and then that was what would deliver the payloads to the device to run their different commands. They would manipulate video conferencing software in ways that we hadn't seen before, but just using it straight off the shelf. And all this while evading, again, normal security platforms, evading logging. And so it was very hard to detect if you were an organization that had an IT worker that was operating like this. So I'm going to pass it off to Luis. You stay on your side of the stage. I'll stay on mine.
No problem.
And he's going to dive deeper into the modules.
All right, so getting straight into it. So just like what Matt went over, they used a collection of scripts, or at least when we did the analysis, we found a collection of scripts that were very unorthodox in how they facilitated their campaign. And we kind of broke it down to 5 specific modules or scripts related to certain activity or functions. So we have a user presence beacon script, a command rebroadcast relay script, input simulation agent, video conferencing automation module, and a network listener module. And we'll go into how they interface with the C2 via WebSockets and so on and so forth. Getting into the first module, this was pretty straightforward and kind of self-explanatory in that this code snippet here is only a subset of the code, but it's really the core functionality of it. Is essentially when this Python script is ran, it'll go ahead and grab a environment variable from the OS, specifically a username. It'll take that value, send a post request to the C2 server via WebSocket, sort of as a way to check in. And when it checks in with the C2, it'll then let the threat actor know, hey, this host is online. We can activate further modules and move forward with any additional activity. So getting into the more interesting module here, sort of going over the WebSocket and C2, but also the ARP distribution of C2 commands. So essentially what the script would do when ran, it would go ahead and connect to the C2 server via WebSocket and just wait for incoming commands, right? So for example, it'll connect, wait, and then once it receives a command, it'll then extract that command from that C2 connection and then append it to an ARP packet and then broadcast that ARP packet to any other hosts that were running a script that was listening specifically for ARP packets with encoded data to then extract that data and then run that command for whatever context that module was running on that host listening for ARP packets. Important thing to note here, I know it may be difficult for some people in the room here to view the code, but when we first saw this script, it was a little bit concerning because we were trying to understand what are they passing through ARP packets. But when we did review the interface, or at least the script, there's an interface variable that was set equal to EN0. So if anyone that uses Mac knows, that's the interface used for like Wi-Fi or connect to a local router. So essentially the context here is this was ran in a laptop farm. So when it would connect to the C2, receive a command, it would broadcast that command over the laptop farm. An additional thing to note as well, just for IOCs, they use Scapy within Python to build this ARP packet. And when constructing that ARP packet, they put a IP source of 0.0.0.0, as well as a destination IP source of 0.0.0.0. And as well as a destination MAC address, obviously the broadcast address, but within the ARP packet creation, they input in the variable HWDST as a MAC address of all zeros. So if you were looking for ARP packets, these are things that you could hunt on and find anomalous activity.
Hopefully North Korea is not watching.
So we just went over the module essentially that connects to our C2 with a WebSocket, takes down a command, takes that command, puts it into an ARP packet, and then broadcasts it over the local network. So in this module, what this module will do is it'll be sitting on that same network. It'll then run this Python script, and it would essentially listen for ARP packets that have embedded commands. Once it receives an ARP packet, it'll go ahead and try to decode the command. Let's say it grabs an ARP packet, fails to do so. Script realizes it's a normal ARP packet, drop it. But if it's successful in decoding that command, it'll then move forward into a function to try to do some hit injection. So essentially, what it would look like is a C2 would send a command like numpad 6 or numpad decimal or shift right, some sort of keybind or mouse control, broadcast it over ARP, and then once that command is received, it'll go to this dictionary and find the associated function to do that hit injection. Another interesting thing to note as well is when it got to that point, it would also try to validate channel IDs and additional variables to sort of rate limit, which kind of gave us more context of how they were using the script. It seemed like they may have been flooding ARP packets within the laptop form, maybe just do something that may have looked more like a mouse jiggler or something to where it just looks like activity on laptops. But just so it's not executing every single ARP packet that's being broadcasted, there was like rate limiting in place so that every so often it'll execute some sort of hit injection to resemble activity. Now moving to the more interesting module. When we found this script, it was concerning because if you were on a security team doing some sort of threat hunting or trying to find any of this activity, this would be pretty difficult to find because this is very out of the box. You also want to note that they did leverage Zoom to get remote control access to a host. We did reach out to Zoom once we found out how this module or script worked, and did let them know that Zoom is being leveraged in this way. And do want to also add another disclaimer is that Zoom was not exploited in any way. This was just Zoom out of the box. They just used the core functionalities that come with the straight normal install of Zoom to facilitate remote control access of a host. So adding that disclaimer.
That's for the Zoom lawyers.
So essentially similar to our rebroadcast relay script, it'll connect to a C2 server via WebSocket and wait for commands. So some of the commands that it'll wait for are like open, create, admit, hide, so on and so forth to facilitate some sort of Python code to automate some sort of workflow of getting Zoom up and running. So in this Python snippet code here, you'll see that there's a function called open Zoom app. Specifically, when it receives the open command, it just starts a process of Zoom. Now, once we know Zoom is up and running on the host and there's a process running, the threat actor can then issue a command from the C2 server called create. And what that will do is that it'll automate the creation of a Zoom call. And the way it does that, it uses a collection, or really it goes between using Apple scripting, which is an OSA script that exists within a Mac, and then Zoom's protocol handler, which is just a nice way of saying keyboard shortcuts that may start a video call, like Command-Shift-V or Command-Shift-S to begin a screen share, right? So essentially the workflow, and when we get to the demo, you'll see, it'll hop between running OSA script to check, hey, is this window in the front? If not, bring it to the front. If we know now it's in the front, go ahead and run this keyboard bind shortcut so we know it'll run. We'll wait, check, okay, did this next window open using OSA script, and sort of do these checks and go back and forth until we have a call with screen share active. So the next thing, once we know, okay, we got our call created, we now have a screen share. The threat actor then joins that call and then asks for remote control access. So if anyone who uses Zoom knows that if you're sharing your screen, someone could request access to control your machine or whoever's sharing the screen. And so a little dialog box will come up asking, do you approve this user to get remote control access? And so the automation the threat actor did in order to approve that request was that it would capture screenshots to identify the admit button by using RGB filters. So upon using the RGB filters, it'll find the exact coordinates of where the button is on that screen, pass it over to a function that'll do some hit injection, like a mouse click. It'll move the mouse to those coordinates, click that button, and now whoever joined the Zoom call now has remote control access of that host. And then lastly, the last module we'll be going over essentially is a network listener script. So this one does connect to the C2 via WebSockets as well, but this one works a little different. It's not waiting for commands from the C2. This one also listens for ARP packets. It'll then try to extract encoded data if it exists within the ARP packet, And if it does, it'll just forward it off to the C2 server. Upon successful exfil to that C2 server, it'll sleep before reconnecting and then wait for additional ARP packets. Now going to the demonstration. So what we'll be going over, we'll be going over 3 demonstrations, the Zoom automation module. I'll show some screenshots of what to expect when you see the GIF plane. Then we'll be going over the hit injection script of how that works and sort of go over the functionality of that script. And then lastly, there's also a third script that we created. This was more of just a proof of concept of how we could leverage ARP further for additional like broadcast of C2 commands. And I'll get more into that later. This is not a script that we discovered during the case, but just a fun POC. So going straight to the Zoom demo, with each of these demos, I'm going to go over screenshots, and so going over what you're going to see, and so you understand what portion is what. So in the red box, that's going to be our C2 server. That's going to be the SSH session that's going to be running a Python script that's going to be waiting for WebSocket connections. You also want to note that the code that we use for the C2 server is something that we created for our lab. We weren't able to recover what the code was for the C2 server, so this is just a script that we created just to interact with the scripts. And then the green boxes that you see here are essentially the same host. It's the same Mac. It's just the one on the bottom right is an SSH session into that Mac. And then on the left is a VNC session to show the GUI and the changes that occur when we do certain commands. So you'll see in the GIF when it plays, when the C2 receives a connection, we'll get kind of like a command prompt or like a shell to issue commands to the agent. On the bottom session, you'll see feedback that we'll get from the C2 and commands that it's going to run. And then in the VNC session, you'll see those changes. So for example, if I run the open command, you'll see on the bottom that it receives that command, understands that command, and then in the VNC session, you should see the GUI changes that take place. So without further ado, let's get into it. So starting the C2 server, I'm running the agent to connect to the C2 server, and I'm running the open command to start the Zoom process. I wait for the WebSocket to reconnect and run the hide command to hide that window. I also want to bring it back into the forefront. So when we do a reconnect here, I'll type out the focus command to bring it back into the foreview. Now let's create a call. So now we get here, run the create command, and this is where it's going to go between OSA script and keyboard shortcuts. Again, this is fully automated. This is not, there's no hand on keyboard at this point controlling Zoom. We're waiting for the screen share. And now we're in. So, well, not yet, but we have a screen share going. There was nothing in the script that showed any logic of how it would show share meeting information. So there's a bit of a gap there. We can maybe assume whoever's running the laptop farm or whoever the insider is could potentially relay this information, or maybe there may be another Zoom functionality that we didn't see that could allow someone to join a Zoom call. But this is me just grabbing the meeting information so I can join from my laptop. Once I join, I then go ahead and ask for an approval request, in which I'll go to C2, run it again because the WebSocket died. The approve command, automated. Now I'm in with remote control access via Zoom, and I'm controlling it from my other laptop. Do also want to note that this is a version 6.2.6. When we did try recreating this lab with the latest version, it did not work. So I think our call with Zoom was helpful. So moving to the second demo, this is the ARP hit injection demo. Essentially what you're going to see here is in the green box, that's going to be our C2 server where we're going to issue commands. In the yellow box, that's going to be an Ubuntu VM that's going to run a team-up session, excuse me. On the top window, we're going to be running TCP dump, filter on ARP packets. So you should see when the ARP packet leaves the host. And then on the bottom, that's where I'll run the agent script, and you'll see responses from the C2 and any functionality that it does. And then the host in the red will be running a script specifically listening for ARP packets. It'll get the ARP packet, extract the command, and run the associated code associated with that command. So just like the other demo, you're going to see me issue commands. You'll see me run keyh twice because, again, there was that rate limiting control. So we did have to modify it because otherwise we'd be here forever. So I did modify it to where once we get to the second command, just continue running a hit injection. So you'll see me run this twice. But on the Ubuntu VM, you'll see we'll have an open connection. It'll receive the command, go ahead and append it to an ARP packet. And then you'll see in the top window, in the TCP dump window, the ARP packet being broadcasted, and then the appended data within that ARP packet as well. And once it leaves the Ubuntu VM, you'll see within the window host, within Wireshark, you'll see that the ARP packet hits the host. You'll see within PowerShell, the agent script receiving that ARP packet and doing functions with it. And then we'll have Notepad++ open, where our goal is to spell out hello by broadcasting C2 commands for ARP. So getting right into it, same as the other demo, we're just going to set up our C2 servers, set up our agent connected to the C2 server, running TCP dump, Wireshark, and the ARP listening script here. Now, the first command we run is key H. Again, there's that rate limiting, so it doesn't do anything yet. But when we go ahead and run it the second time, you'll see that Notepad++ gets updated. And with each command, just do note, the Ubuntu VM, you'll see the ARP packet leave first from TCP dump. It'll then hit Wireshark. And then from there, you'll see in Notepad++ it being updated. And again, the thought process here is, I don't think someone's on the C2 running commands like the way I am. I'm sure there's some functionality where they're just kind of throwing out HID injections to sort of, broadcast over the laptop farm. But essentially, right straight from the C2 commands being broadcast via ARP, we're able to spell string hello, strictly using ARP packets as the way of transmitting that command. So again, disclaimer, this is not a script that we discovered within the case. This is what myself and the team created. This is a very interesting case because it was very unorthodox in how they ran their campaign, right? Usually when we get into an IR, we'll see a host connect to a C2, but if we want additional commands being ran on additional hosts, those additional hosts will connect to the C2, right? And then they'll be issuing commands that way. What was interesting here is that the ARP packets were the method of propagating C2 commands. So in the case, or the concept of this case, we just saw it used within a laptop farm. But what if this is something that they could be using for other campaigns because it's a tool within their toolset, right, of using ARP in that way? So this is just more of a proof of concept code of, hey, can we leverage this to do more nefarious activity? So the purpose of the script is it'll connect to our C2 server. We'll issue commands the same way as we did before. And then there will be a listening. So the red box is our C2 server again. The green box here is going to be our Ubuntu VM that connects to our C2 and receives commands and then broadcasts it via ARP. And then we have our box on the yellow box, the host in the yellow box, listening for ARP packets to then take that encoded data and then actually execute it within Bash, right? And our goal here is to execute commands as well as try to exfil file content via ARP. So you'll see me type out commands like exec and then cat etc password. The exec is just a keyword that I use to let the agent know we're executing something, and then what command we want to run. On the screen here, and the text a little small, but I'll still walk you through what's happening when we watch the demonstration. On the left side, again, that's going to be our Ubuntu VM that's connected to our C2, receiving commands, and then broadcasting those commands. So you'll see on the left-hand side that it'll receive the command, we'll base 64 that command, and then append it to an ARP packet, and then broadcast it out for any listening agents to receive that base 64 command, decode, and execute, right? So in this instance, we're doing a cat etc password. On the left side, we prepare it in an ARP packet, broadcast it, and then the host on the right receives that ARP packet, decodes that embedded payload within the ARP packet, decodes the base 64, and then as you can see, it executes cat etc password. Important thing to note as well is that normal ARP packets are about 28 bytes. So when we did our testing, we found that the max size is about 64 bytes. So if we really want to exfil like etc shadow or etc password, right? 64 bytes is not going to be enough. So we added logic within the scripts to, okay, we know 64 bytes is our max limit. Let's just break the file up into 64 byte max ARP packets. And so you'll see when I run these commands, in the TCP dump window on the top, you'll see the segments of etc password within ARP packets being broadcasted back to our host on the left, who's also listening for ARP packets. And then the host on the left will actually take that data, reconstruct it, and then send it back to our C2. So just like the other demos, is us just setting up the C2 server, setting up TCP dump within our team up sessions, and then running our ARP listener, and then running our agent connecting. So right now I'm just running exec who am I get the response of root, so just proving we can get execution. Now we're doing exec cat etc password. which you now see the content of Etsy password being broadcasted via ARP package to the host on the left, the bottom left, that's now reconstructing it and sends it back to our C2. I messed up here. I put cat Etsy shadow because I forget I added this keyword for exec, so it's not going to work. But when I properly use exec cat Etsy shadow, we'll see the same activity where the host on the bottom right is sending the segments of that file back up to the host on the bottom left, whereas C2 then receives the file content of Etsy shadow. So again, this is just a proof of concept of how ARP can be leveraged for more nefarious activity. Recommendations. So what can we do to defend against this activity or to help detect it? So the first two kind of go hand in hand. ARP broadcasts, finding anomalous ARP broadcasts being broadcasted within the network, or at least hitting hosts that belong to remote workers, right? So seeing ARP packets that contain that 0.0.0, the MAC address of all zeros, or even seeing ARP packet sizes greater than 28, right? Usually normal ones are going to be at 28 bytes, so that may indicate some activity that there may be appended data into an ARP packet. The MAC address oddities, that goes back to what I noted, just if there's any like weird MAC addresses that just don't make sense or just seem to be spoofed or are just completely zeros, this may be an indicator of this kind of activity. WebSocket traffic. I think if there was any actionable item any organization can take today to help identify specifically the activity in this case, it would be this WebSocket traffic. Just because trying to investigate on ARP broadcasts, it seems a little bit difficult, but actually looking at what HTTP traffic is going through your network should be more, it should be more obtainable for an organization to actually do this and be an action item, right? So just looking for any weird repeated WebSocket traffic, weird domains, right, to help find this activity. Input simulation. So within the scripts that we looked at, the main library that was used was PyInput, that's PYNPUT. So maybe scanning for libraries that do hint injection or PyInput, things of that nature. What packages are being used in random scripts, right? Like Scapy, your developers or DevOps actually need to be using Scapy or PyInput, right? As well as looking for any processes that may be interacting with something like on a Mac, a /dev/HDD0. That may indicate some potential hit injection that may require further investigation. And then lastly, the Zoom protocol. If you're seeing things like bash starting up Zoom or command prompt, right? A little weird, should investigate further. You could also go to a web admin portal for Zoom and go ahead and look at your admin logs and see what kind of activity is happening within Zoom, and kind of take a step further and see, are we seeing any activity that we noted on these slides?
Yep, I'll cover last thoughts. So not just technological recommendations, but really organizational recommendations as well. Workflow control. So these attackers exploited HR, right? And there's always that communication gap between security and different departments within the company. We're always harping on people to lock your screens and all that good stuff. And so there's always that issue. But this is really something that the organization has to collaborate on, right? How does HR vet these legitimate, what seem to be American citizens that have backgrounds and check all the boxes? And they do the background check and then get hired. What steps can they do? And that's something that we're kind of pitching out to you as the audience to kind of figure out on your own and within your organization. But with that, it is affecting the trust boundaries, right? We're trusting other parts of our organization to do their due diligence while we do our work, right? Did HR do enough in these situations? Sure they did, but we need to work on evolving and figuring out how we can identify these types of threat actors. And that kind of rolls up into evolving detection and protocol thinking, right? So not just ARP, but WebSocket. I mean, ARP is one facet of how these threat actors are hiding their methods. We've recently DNS with TXT records, and there's always just something, right? They're always evolving, always figuring out some way to evade detection. So it just takes a matter of thinking outside the box. And I hate being cliche like that, but as defenders, we always have to be kind of thinking as the attacker, right? What are the next steps? What are the ways that they're going to be affecting us? It's not just Zoom. It can be any web conference software, right? So thinking about that as well in your organization. So I want to leave you with that. And I think, yeah, so thank you for attending. We'll take questions. And then I just want to make one more statement. Sygnia is hiring, so if anybody's interested, we have positions available.